Imagine spending over $10 billion building the most advanced space telescope in history, and then realizing it might only last a decade. The James Webb Space Telescope, humanity's most ambitious eye on the universe, is out there right now, 1.5 million kilometers from Earth, peering deep into cosmic history. It's already given us breathtaking images of ancient galaxies, peered into the atmospheres of distant exoplanets, and challenged our understanding of the early universe. But here's the unsettling truth: Webb's mission lifetime is limited. Not by its instruments, not by its solar panels, but by something far more mundane: fuel. So, is Webb really doomed to stop working after just 10 years? And what can NASA do to keep it alive longer? Let's find out. Before we talk about how long Webb will last, we need to understand why it's so unique, and why losing it would be such a huge blow to astronomy. Launched on Christmas Day, 2021, the James Webb Space Telescope is the successor to the Hubble Space Telescope. But unlike Hubble, which sees mostly invisible and ultraviolet light, Webb is an infrared telescope. This means it can see through clouds of cosmic dust and detect the faint heat signatures of objects billions of light-years away. Webb's primary goals include studying the atmospheres of exoplanets to search for signs of life, observing the first galaxies that formed after the Big Bang, understanding the birth and evolution of stars and planetary systems. To do this, Webb needs to be kept extremely cold, at around -233 degrees Celsius, and far from Earth's heat and light pollution. That's why it was placed at the second Lagrange point, or L2, 5 million kilometers away. Here's the problem. Webb's location at L2 is great for observations, but it also means it can never be visited for repairs. And, to keep itself in position, Webb needs to perform regular station-keeping maneuvers. These are small rocket burns that counteract the Sun's and Earth's gravitational tugs, keeping Webb in its orbit around L2. It also needs fuel for momentum unloading, basically, using thrusters to keep its orientation stable when its reaction wheels become saturated. All this fuel is carried in Webb's tanks, and once it's gone, there's no way, at least right now, to refill them. NASA's original mission plan estimated Webb had enough fuel for about 10 years. That's not because they couldn't put in more, but because adding extra fuel means more mass, which means more cost and risk during launch. Now here's the good news. When Webb launched aboard the European Ariane 5 rocket, the mission planners got an incredible stroke of luck and skill. Ariane 5 delivered Webb so precisely into its transfer trajectory that the telescope used far less fuel than expected for course corrections on its way to L2. This single factor instantly extended Webb's projected lifetime from 10 years to more than 20 years. In space missions, every meter per second of saved velocity counts, and Ariane 5's pinpoint accuracy meant Webb kept a huge reserve of fuel. But launch precision is just the beginning. NASA is actively working to make Webb's fuel last as long as possible. 1. Precision pointing. Every time Webb changes where it's looking, it needs to rotate. By optimizing the sequence of observations, mission planners reduce unnecessary turns, which saves reaction wheel energy, and in turn, saves fuel for momentum unloading. 2. Efficient station keeping. Webb's orbit around L2 is not perfectly stable, but NASA uses extremely careful modeling to minimize the frequency and size of correction burns. 3. Software optimization. Even small updates to Webb's onboard control algorithms can slightly reduce fuel usage over time. It's like extending your phone battery life by turning off background apps, except in this case, it could mean years of extra mission time. Here's where it gets interesting. Technically, Webb wasn't designed to be refueled. Its fuel ports aren't in a position for easy robotic access. However, NASA and other space agencies are researching robotic servicing missions, like the upcoming OSAM-1 project, which will demonstrate refueling and repair of satellites in orbit. If a future servicing spacecraft could reach L2 and safely dock with Webb, it might be possible to top up its tanks. But right now, this is more in the realm of possible future technology than an active plan. Even if fuel weren't an issue, Webb won't last forever. Space is harsh. Its electronics are constantly bombarded by cosmic rays, which slowly degrade their performance. Its sunshield materials will age over time. And eventually, key components will wear out. That's why NASA prioritizes its most ambitious science goals early in the mission, to make sure they're completed while Webb is at peak performance. If Webb lasts 20 years, the possibilities are mind-blowing. We could detect the first biosignatures, chemical hints of life, in the atmospheres of Earth-like exoplanets. We could watch galaxy formation in unprecedented detail. We could uncover entirely new phenomena we don't yet have names for. And by the time Webb's mission ends, its successor, the Habitable Worlds Observatory, could already be on its way, ready to build on Webb's legacy. The James Webb Space Telescope may not watch the universe forever. But every extra year it operates, every photon it captures, adds another piece to humanity's cosmic puzzle. One day, Webb's fuel will run dry. Its mirrors will fall silent. And it will drift quietly at L2, a frozen monument to human curiosity. But the discoveries it leaves behind will shine for generations.